Hello.
Morning.
Morning.
Hello.
I'm Barshan. I'm Morgan. And it looks like Ashu's here as well. So I think Barshan probably has an update for us, and then maybe Ashu as well. Why don't we get on with that?
All right. So I'll start with the previous week's update.
Okay.
We didn't have a meeting. So I'll share my screen. All right. The previous week I started training, and let's see how it went. So yeah. So this was the pre-planned that I actually wanted to go ahead the usual timeline because I thought that I might uh, get into a speed breaker, or I have to change my path. Uh, So the plans I had last time was I start the training and prepare evaluation at least, and then some of the setbacks were that each epoch took more time than expected, so I had to optimize that. And so I also eliminated some of the performance bottlenecks, like it was running on the CPU a lot, and some fetching problem was there, fetching the data, and then a new array was created, and then it was deleted, and then a new array was again created for the next epoch. But I changed it to changing the values of the array instead of deleting and then again creating one, since it took more memory. And so yeah, so this was the first setback that I had. I just listed a few setbacks which I had during the training. So initial baseline fails because some of the embryos had a like I put down a max node of 1024, but some of the embryos had a max n number as 1086, so it was exceeding that inside the DRL gate. Uh, However, in the late stage, the embryo goes up to like 2434. So I changed the max node parameters to 2500 across all the modules, like the DRL, the DNL, and the EM. So, so it was training at approximately 17.5 minutes per epoch, and primarily it was restricted by the CPU bound because we are using NumPy operations. NumPy operations are run on the CPU. We can't run it on the GPU. So during this, there was a lot of page faults, which I said, like there were like 72,000 pages per time, so that's a lot, and the memory allocation reached around 17 GB per embryo in the forward pass, which is like a lot of CPU memory to be uh, consistent in that. And then I trained the model on CUDA, uh, except the NumPy arrays. After those, the model was trained on CUDA. So the complete dataset consisted of 260 embryos for the 5 epochs, and we employed a training split of 80-20, so 80 training and 20 test, and we had 52 validation samples. And this is the metrics that we had. So the train accuracy increased gradually, and the validation was also started at a high point, and it was increasing from there. And also we can see the loss was also decreasing uh, gradually. So this is some of the screenshots that we have. So this is the first epoch. You can see the train loss is 69%, and the accuracy is like 0.25. But then we have the accuracy of 0.5 during the validation, and the accuracy increases as we go along. Like the training accuracy also increased till 96%, and the validation also increased till around 96%. So it matched the training and the validation accuracy. So this is the training process. I also took a screenshot of that, and so I was prepared to make a visualization like a web app or something, because I thought maybe if I put up a demo or something in my blog which is really interactive for the users or the people who come and see it, so that would be better. So that was it for the fourth week.
All right. Yeah, looks good. Looks good. So yeah, did you?
Yeah. So
So
yeah,
what is it? Where are you at right now?
so actually I hit a speed breaker. So the thing is that what I actually classified according to my proposal was I had to classify the mutant and the wild embryos.
Mhm.
The wild embryos are the one which don't get affected in any ways throughout the process until it's a full life, and the mutant one are the ones that get affected, and like it confuses itself. Like if a anterior part of the cell gets confused with like some other part of the cell, that's what happens in the mutant one. I guess I read it somewhere.
Well, some
It gets
mutants. Yeah.
yeah.
So some mutants, like in C. elegans, we have defined mutants. So we have wild type, which is like the uh, wild type genome, which doesn't have any defined mutations. And then they have these defined mutations, these strains that they backcross, and they usually have some sort of phenotypic effect. Sometimes not, but I think the ones in that data set have some phenotypic effects, and that's why they're
Yeah,
interested in it. And so you'll see some aberrations sometimes in the developmental
mhm.
process, but sometimes it's
It was
not in
some
the developmental
yeah,
process. But yeah,
like it was something POP1 RNAi phenotypic effect was mentioned in the EPIC dataset. So
yeah,
yeah, so we have those. So basically, I was approaching two ways. Like one was classifying the wild and the mutant embryos, and the one was sulfate and classifying like how each cell is going to end up in which part of the worm at the later position from a single time step. So the last week I was focused on this wild and mutant embryo type. So over there, I also made a PPT on that, so I'll just share that. It'll be easier.
okay,
Okay, so this is what I'm classifying right now. Like I'm training the model to look at an entire 4D development trajectory of an embryo and categorize it as a wild type phenotype or a mutant phenotype. So the basic thing about this model's approach is that like the EM, the edge attention module, is basically once it successfully flags an embryo as a mutant, you can always work backward and check at the attention weights at which specific cell to cell physical connection or at which exact time step the development timeline model highlighted as abnormal, like from which position that it was abnormal in the rest of the evolution process. So these are some of the cell to cell attention weights over the time step. Uh, so uh, So yeah, at time 30, these are the connections. Like there were eight active connections, but this among this three took more attention as to what ended up in the like this for the wild type embryo. So these connections were the most effective to the reason like it ended up as a wild type embryo. And at each time step we have this attention at like how it like these are the most important ones which leads up to this the type of the embryo that it is, and it's also like a graph of the time step at which time step it goes up and the score increases. And uh, so I also prepared a UI. This is basically the colors are based on lineage markers, like the cyan is for the AB, yellow is for MS, and green is for the E. So and they are sized by the nuclear volume of each. So the thing is that this is the like it didn't turn out as expected. Like the attention scores were very like it was one for like completely one or 98.6 and everything. So I need to work on that part a bit. Like uh, it's like the visualization is fine. Like I can put this in my blog and everything, but like it also shows the average attention weight at a point. Like I can just control the timeline at and it's also movable. It was yeah. So frame by frame, I can just check uh, how it's moving and at what point how much attention we have. Which connections have the most effect on the end part of the embryo. So this is a pertubed and this is a wild type. This is a wild type and this is a mutant. So we have the changing of that. And so the next process I am focusing on is like that cell fate, about how the cell of each embryo will finally go into, like the anterior or the posterior part, that I'm focusing on. And the attention scores as well, like those are like pretty vague for now, in my opinion. Like maybe the training data is less, or some reason like that. So that I have to look through, or maybe some other data set. I can, like, the code will stay the same, of course. I have to just change the mm, uh, values which are being taken, or the features are which are being taken. So yeah, since I'm already ahead of schedule, like I also have visualization, so I can just work on that itself, like perfecting or making it explainable for now.
Yeah, that looks good. I like this interface. Um,
Yeah.
so, is this something that you? How did you make this?
The front end was, of course, I vibe coded it because I'm not into
It's fine.
designing and stuff. Yeah,
Yeah.
but the I had to fetch the data into that code, of course. So the basically the model brings out this data, and this data goes into the script of this UI, and the script displays this time to time. So I have a
Okay.
whole JSON file which contains all the attention scores and everything.
So you can play around with it. You can put different scenarios in
Yeah.
here.
So basically, I can just put in that I want to analyze this embryo, and it will my model will fetch out a .json file which contains all the attention scores or whatever the output is, and that JSON file can be inputted into this UI to display the to play around with it basically.
Yeah. Yeah, this looks good. Yeah, thank you.
Yeah,
Um,
I think I might, if I can, I'll put this kind of UI in my blog if it's possible. I've never put an interactive UI in a blog, so I have to look into that. So after
yeah,
I put that in, maybe like users can of course check it out.
yeah. Can you also push this code to the GitHub repository just
Oh
so we
yes,
can have it? Yeah, yeah, yeah. This
Ashok
looks
present.
great. Oh yeah, thank you. Yeah, no, that looks great. Thank you, Barshan. So yeah, you're preparing a pull request for this week.
Hmm. Yes.
Okay, and then you'll probably put a blog post out as well.
Also on Monday, I'm planning to put up a short PPT since it's the mid time, so I can just cover up all that has been done till now. This
Okay, yeah,
presentation that might look good.
that would be good. Yeah. All right, thank you, Barshan. That was great.
Thank you.
Looks like Sarrah is here. Hello, Sarrah. Ashu, did you have an update for us?
Hello, sir. Am I audible?
Yes.
So currently, I am working on the training phase of the model. Like I have built the convolution layer, and I have performed the test on raw data sets. And before training, the data sets and accuracy are very sparse. And now I am working on the training model. So after training, I'll compare both of them. And also, I was reading a paper on PINs, that is the physics informed neural networks, that we have discussed one in one of our cognition meeting, and
Yeah.
that I was working on a space project also. So the, that paper is very helpful in that, like it uses actual physics and machine learning. I'm exploring that paper also.
Yeah. That sounds good. Yeah, we talked about that somewhere else too. I think we talked about it in one of our Saturday meetings, but I can't find the reference to it. Or maybe DevaWorm. I'm not really sure. I couldn't find the reference, and I looked back because I know that this came up. This has come up maybe in our cognition meetings earlier, several years ago. So I know Morgan, I think, is interested in that area too. So yeah, we'll have to follow up on that. That's a interesting area where people are looking at these physics inspired models of neural networks. So they're looking at kind of like different aspects of the sort of the statistical mechanics of neural networks and other things like that. Yeah, so it's great. Yeah, I look forward to hearing more about that. Yeah. All right. Thank you, Ashu. I don't know if Sarrah or Morgan wanted to give an update.
Yeah, so sorry, just
There we go.
yeah, I just one comment from earlier. You know, Jax is a great way to easily modify NumPy to use GPUs. I don't know if you've been looking at that, Barshan, but yeah, I've got a new kind of is both a benchmark and a set of computational microscopy algorithms that are using, in some cases, physics-informed neural networks to do. I'm using the Berkeley single cell microscopy or computational microscopy benchmark. And this is from Laura Waller's lab. I'll drop links in later, but you can find my repo on my GitHub. It's bsccm-jax is the repo, and yeah, so some cool stuff. She's someone who's I've been playing with microscopes, as you can hear,
Yeah.
or as you can tell, and so we had an intern in the lab build one of these open flexure microscopes. It's an open source hardware microscope, and the I've just been looking, and you can see this on the GitHub too. Is I think it's OFM, open flexure microscope. Yeah, OFM-CM for computational microscopy. So, like, can I change the LED light source to an array and do differentiable phase correction or phase recovery, and that's one of the things that this particular Berkeley single cell data set is designed for, is to kind of benchmark some of the kind of computational microscopy work that Laura Waller works on. And yeah, it's cool. You can take these light images and like infer the fluorescence that you would get from these particular cells, or yeah, some other things. It's kind of virtual staining is a topic. Yeah.
Oh
So
yeah.
I just saying, like, how as well, like, how easy is it to kind of make a, if you will, a toy microscope that can actually demonstrate some of these principles. So there'll be an open source hardware component of this.
Okay. Yeah. Let's take a look at I see that Barshan posted the repo in the chat. So this is bsccm-jax. So this is looks like this is some virtual microscopy. Yeah.
Yeah, well, it's like real microscopy data that is from Laura Waller's lab at Berkeley. She's this amazing, computational imaging developer. And yeah, she's got some great videos on YouTube of her lectures. Sorry, the train's coming. Um, but and then the JAX is the software that can process that data and make predictions that you can compare against their baselines.
Yeah, you've talked about the JAX-KIDGER pipeline before, and you have this SCICO computational
Yeah.
microscopy branch. Okay.
Yeah, that's a
So
Los Alamos package for a lot of computational imaging as well. Yeah.
okay. So that then you can run this in Napari, or this interfaces with Napari, correct?
Yeah, I'm actually making the OpenFlexure microscope. It's kind of designed to run on a Raspberry Pi, right?
Yeah.
But I'm like, what if you had a workstation with say an NVIDIA GPU?
Oh yeah.
Would you be able to, with again just an inexpensive change in the LED light, the LED source, could you make it into, a phase contrast microscope?
Okay. Okay. Yeah, it looks pretty good. Yeah. So this is a standalone project, not a fork. It uses bsccm as a data source and draws methodologically in TN and Walker, DPC and STM. Okay.
She's got. I mean, it's a fork in the sense of like I'm using her data set. Like she's got a GitHub project of BSCCM. Yeah.
Oh, okay.
But
So
she didn't have any associated software with it. So I was just trying to have like a nice open source stack that you could use to start using it as like more as like a machine learning benchmark.
okay. Yeah. Well, that looks good. Thank you, Morgan. All right. Sarrah, how are you doing?
Hi everyone.
Hi, how are you? Yeah.
Yeah, I mean, I'm mostly just swarmed up with my full-time job. So not been doing anything much lately. Uh, I haven't been on a lot of the meetings as well, and today I just thought I'll at least join that and try to be more regular. And I do want to try to work on a paper as well, but it's been like getting procrastinated for quite some time.
Yeah.
But yeah, hopefully I can get something working and I have some better update next week.
Okay.
Right. Yeah, and also I had got to see a little bit of Barshan's presentation. But yeah, excited to see that as well. Excited to catch up.
Yeah, thank you. Yeah. Well, that's good. All right. I wanted to talk a little bit today about another topic in open source. So I have 3 articles today, and this is something that I kind of was thinking about, and I don't exactly know how to describe it. So we'll see what this looks like. So this is, I've been thinking about like a lot of the conversations we've been having about agentive coding and about sort of being on the edge of innovation and then how that's impacting open source, sometimes negatively, but sometimes positively. And so, a lot of times we do software development, and software development, of course, is a very fast moving area. And there are different methodologies for managing those kind of projects. But a lot of times, what you're doing is you're really kind of at the edge of a lot of things. So a lot of times you're at the edge of licensing or the edge of like workflows, and we saw that with the Morgan's project, or the edge of like technology itself. And so, that means that there's no template for what you're doing. So you have to kind of develop things on your own. Sometimes it's kind of figuring out processes, building them, and then refining them. Or sometimes it's figuring out like kind of the licensing and how things should be used. So these articles are on this idea of the sort of the edge of technology, and it's like kind of beyond the state of the art, because the state of the art is usually a buzzword for some corporate thing that they kind of put out and market, and it's the state of the art is usually like kind of this is this new thing that we're bringing to market, and this is like the latest technology, and there is this marketing aspect to it. But what I'm talking about is really at the edge of technology, at the edge of process, at the edge of like what we've done before. Okay. And so there are a lot of projects like that. Sometimes you're dealing with things that people haven't thought of before. Sometimes you're dealing with maybe you're writing software for a new technology, or you're developing a new computational technique, or you are working with a newer programming language, or you're just coming up with something totally new. And, no one has any process. So this first article is on navigating the edges of technology in software development, bleeding, leading, dull, and rusting. And this is kind of we'll get into why what the title is in a minute. So this is from this blog, Technology Edges. And so this is from 2024. So in the fast evolving world of software development, keeping pace with technology trends is both a necessity and a challenge. And so this is, we have to keep pace with a lot of things. And certainly a lot of technologies it's not just, generative AI, or it's not just like, the latest software release or whatever. It's always a continual challenge to keep on top of new technology trends and how you can leverage those for your project. So companies and developers often find themselves making critical decisions about whether to adopt new technologies, which we'll call the bleeding edge, wait until they mature, which is the leading edge or cutting edge, or continue using older, more established technologies, what I'll call the dull edge and rusting edge. Understanding these distinctions and implications of these choices can significantly impact both the development process and business outcomes. So this is one way to view this. So you have this sort of evolution of technology where you have things that kind of are introduced and you can use them right away, and they may not have a process associated with them, but you try to mine them for their potential. And so a lot of people will do that because they figure if you're the first one in the neighborhood to do something, then you kind of own that thing, or you get a leg up on using it, and you gain that experience, and you kind of corner the market, so to speak, on that technology. But then, of course, that comes with risks, right? So sometimes you adopt a technology and it fails to produce, or it fails to give a sort of a payoff. And that's true whether the technology is really successful or useful or not, right? I mean, in some people's hands, they might just dabble with a technology, or they might not understand its full potential. So they fail early because they can't seem to master a process for using it, or they don't really understand the potential or whatever. And so that is a risk that people run. Then, of course, you have the second category, which is the sort of the, I guess he calls the first thing the bleeding edge. And then there's the leading edge or cutting edge, which is where you have technology that's maybe a little bit more mature by the time you adopt it. And there may be some processes that are kind of, people have already kind of abstracted out the processes for working with this technology, but they still haven't really realized the full potential or the really established use cases. So you are left with this technology that maybe you didn't gain that first mover advantage from adopting it early, but you still use it, and you still have a risk because maybe there aren't established use cases yet. So you're the one who has to sort of bear that burden to develop the good use cases and kind of take full advantage of that technology. And then, of course, there's this category, the dull edge or rusting edge, and that's this more conservative strategy of waiting until there are these established use cases for using a technology. So, when we talk about, like we were talking last time about generative AI. And some people, have been using these tools for a while. They've kind of been experimenting with them and building out maybe some sort of ad hoc process for using them. They may not have use cases, but they are using them in their projects. And then, of course, you have people who are doing this now. They're using agentive AI or generative AI for, things that are maybe kind of developed workflows, but they haven't really developed really good use cases for them. And so, maybe there's some opportunity there for innovation and for other things. And then, of course, there are the third group where, eventually they'll start using these technologies once the established use cases come to bear. And so, if you're familiar with the Gartner hype cycle, I think this is a good thing to contrast this with, because the Gartner hype cycle is where you have different technologies that follow this curve where you sort of introduce a technology into a market or into the world, and people start using it. And there's this sort of initial excitement about the technology, and it culminates in this level of hype that ultimately is way too out of sync with what the technology actually is. And I'm sure you can point to many examples in the open source sphere about this. So I actually, in my project management class, have a Gartner hype cycle curve for open source technologies. And the idea behind the hype cycle is that every field will follow this general trend where you introduce a technology, it goes up the hype cycle up to a crescendo of hype. And then, of course, people adopt this technology while it's being hyped. And then there's this sort of plateau where there's massive amounts of hype. But maybe since a lot of people are using it, they realize that maybe the promise is somewhat off of that hype. And so there's this correction period, which they call the trough of disillusionment, which is where people stop using the technology because they say, well, I don't know how to use this technology, or I didn't see the point of it, or I didn't see the promise. And then there's this fall off. And then you continue on and you get this plateau of productivity, which is a second plateau, which is more stable. That is where the established use cases lie, and people have to use it in their workflows quite extensively. And it's sort of this mainstream technology. So if you think about version control, for example, there were early versions of version control. Version control didn't quite have the hype of maybe something like generative AI, but it did have this period where people were trying to build good version control systems, and then eventually you get these established version control systems, which are more widely used today. So this is kind of the thinking about this kind of model of early, middle, and late adopter, or what they call here bleeding edge, leading edge, and dull edge or rusting edge. So they talk about bleeding edge, innovation at a risk. The term bleeding edge refers to a technology that's so new it hasn't been widely tested or adopted. This could be like a version 1.0 or preview releases, or like in a technology sense, just something that there's like maybe very early versions where you have to put the pieces together yourself. We talked about microscopy. There's a lot of experimental microscopy where people just kind of hack things together and try to develop new technologies. And then eventually, people might build a prototype. They might then, test the technology, and it gets to be adopted more widely. And then you start to get like more refined products, more refined protocols for using them. And then it becomes kind of moves along that path towards the leading edge, and then eventually the rusty edge. So for startups or tech-centric businesses aiming to disrupt markets, bleeding edge technologies may offer the crucial differentiation needed to stand out. However, far more established businesses who hope to build software that will last years, for those entities, the frequent changes and outright failures common to bleeding edge technology are often better avoided. So it just really depends on what your, the mission statement of your organization, what strategy you pick. And the payoff is different for each kind of organization. If you're a organization that doesn't have a lot of legacy interest, you might want to disrupt the market to gain an advantage. But if you're an organization that is very well established in its ways, then maybe that's a risk to you, is to do this work at the bleeding edge. So this is so they say some examples of bleeding edge technologies that companies who bet on them include AngularJS and Silverlight. So again, sometimes companies can adopt things and it can hurt them. Sometimes it can help them. And certainly, like you can see this with generative AI, where sometimes legacy companies will adopt the technology and then understand what the actual use cases are, and basically get burnt, and then they go down this trough of disillusionment and say, well, this is not a technology worth investing in, even though it may actually help them if they had a more defined use case. So this is, these are the pros and cons of this bleeding edge. And, it's really just kind of, again, about organizational culture, but also about organizational strategy. The leading edge is established and evolving. So this is where we have technologies that have emerged from their initial testing phase and have been proven effective in world applications, although there aren't really established use cases yet. We just know that there's some effectiveness of it. These are typically at least version 2.0 releases and have garnered an active community and robust support. Organizations looking for a balance between innovation and reliability often opt for leading edge technologies. So the pros of this is that you have maybe a larger pool of people who know how to use the technology. You have regular sort of interactions with community members, so people know what they're doing. You have good, robust tech support. You have strong community support, and you have this lower level of risk. But also, there is this, there's less opportunity for, say, market disruption. There is some risk of obsolescence as newer technologies emerge, and possible limitations if the technology does not evolve quickly enough to meet emerging needs. Okay, so that's our leading edge. And then a dull edge is, so the leading edge is, the subtitle here is established yet evolving. The dull edge is stably pervasive yet fading. I don't know if fading maybe is the right word. You might have something that's very mature as a technology, but it's basically not the cutting edge. So no longer sharp or leading. The dull edge refers to tech that is tried and true. It's still in wide use, but mostly out of inertia. It's lost its shine. It's often difficult to upgrade because many systems integrate with or depend on it. It's dull metaphorically because it's not often as efficient or effective as modern tool sets. It often carries a stigma amongst developers of being dull to work on or work with due to its age or lack of continued innovation. So, this is kind of a category that I would break up into multiple pieces here. So when they refer to the dull edge, they're referring to things that are sort of old guard technologies or things that maybe are on their way to obsolescence. But I prefer to think of this as maybe more of like something where you have established use cases. And indeed, older technologies often don't need as many updates, simply because, what are you updating? A lot of times organizations, especially well-established organizations, or if you're working within a well-established workflow, they need that stability where not everything is being constantly changed. And so this is, again, not a bad thing. It's just that it's not the flashy innovation that we kind of come to expect sometimes of open source. So, there is this risk of obsolescence. People maybe stop working on it because it's not the sexy new thing. But then again, you do have this broad familiarity and reliability and stability, and the reputational aspects of it outweigh the lack of innovation. So that's their model here. And then, of course, you have your declining technologies, which is the rusting edge. The dull edge is stably pervasive yet fading, and then the rusting edge is declining, where something is actually being push towards obsolescence because, and sometimes rusting edge is about technologies that no longer serve their purpose. So sometimes that's a thing too, where you have things that actually just lose their relevance entirely. And so that's also another thing that happens in a lot of open source projects. Sometimes projects fail because they are about these sort of obsolescent technologies or declining technologies. Other times, there is this sort of aspect of we need to push older stuff out of the way so we can do the newer stuff and innovate. And I don't necessarily think that's true. I think you can use older technologies and you could find new angles to make them more, to push innovation just as much as you can push innovation with newer technologies. It really is a matter of like innovation being a separate concept from all of this. So that's this article. And so that's their model. This article is the pros and cons of using cutting edge technology in software development. This is from the Unosquare blog from 2023, and it really is. Well, they have OpenAI here as the picture, but really the idea here is this sort of strategy or this calculated strategy that you have to come up with to use cutting edge software and bring it into your organization and not lose the bet, basically. So this is about cutting edge technologies. This is contrasted with bleeding edge technologies, which we saw. They refer to bleeding edge technologies as things that aren't quite ready yet for mass adoption. So this is where we have this distinction between bleeding edge and cutting edge in terms of mass adoption and this sort of maturity of the technology. There is this whole topic of open source maturity models, which I won't get into here, but to think about like your organization in terms not of what you're doing in your workflows, but how mature is everything you're doing in your organization? Do you have components that are immature? You have components that are mature, and that helps organizations when they do that audit to think about where they can improve their process, where they need to keep an eye. They can't manage cutting edge technologies the same as established technologies. And so that helps organizations really zero in their resources on where they need to focus on maintenance, where they need to focus on sort of maybe helping contributors through a process, etc. So then they say what technologies are considered cutting edge in 2023. And this is, of course, now with 3 years of hindsight. So now we can say, these are maybe still cutting edge or these are established technologies now. So they talk about AI, of course, low code development, which is where you're using things like an interface or other types of methods to not directly engage with the code, but to build things with, kind of a, something that isn't as technical as diving into the code and, building something that way. And of course, the disadvantage of low code is that you can't easily debug the program because you're just using like these high level, maybe it's usually like a GUI or something where I've seen low code interfaces where they have different block models and things that you manipulate. And of course, that can be useful for kind of thinking about the higher level aspects of organizing your code in your application, but some of the technical details in terms of debugging and other things get kind of swept under the rug. And this can be kind of an inconvenience for open source organizations because their maintainers usually have to do all of the technical matching there, where they have to kind of find the bugs and report out the technical problems with the low code contribution. Then there's serverless computing, which I think is probably still cutting edge or maybe even bleeding edge. Microservices, natural language processing, and so those are the things that they define as cutting edge in 2023. I would say a lot of these are still cutting edge, although maybe some are moving in the direction of more established technologies. So So this is what are the advantages of using cutting edge technology in software development? And so why make that gamble? Or why not, how do you prevent yourself from losing that? And so there are a couple of different points here they make. It allows sometimes for improved performance and efficiency. So sometimes we adopt things at that stage because it offers faster, more efficient solutions to problems. And if that gain in productivity or that gain in efficiency is great enough, then that's a great bet to make. But of course, sometimes it doesn't deliver as promised. And so now you're left with something that's sort of less worked out, but also not as efficient as you thought. And so what's the point? Sometimes, there are a lot of, when you get these new technologies, there are a lot of promises made about efficiency, productivity, quality, et cetera, time to market, lower development costs, improved user experience. A lot of times these technologies don't deliver, or sometimes it doesn't deliver in your hands. So when you adopt something, a solution, you need to be able to have support in your organization to make it work. And so if you don't have that support, then it's harder to make it work. And a lot of people don't really understand that, I think, or they don't appreciate that you need to have people who can actually make that technology work. Then there's access to new and advanced features. So, this is where we get a lot of great things that come out, and there are a lot of things that are always coming out that are new. And you can embrace the new all the time, but then that also has a back end effect, both in terms of technical debt, which is where you have this, you make an investment in something new and then you have to maintain it later. And of course, a lot of people don't think about the maintenance part, so that gets neglected. But also in terms of training. So like people will adopt a new thing, they have to learn it. You have to give them time to learn it. And that learning process takes a chunk out of what you otherwise would be doing in your organization. So if you're always learning new things, you don't have time to actually do development. There are competitive advantages in the marketplace. So this is where, again, a lot of times people are looking for that competitive advantage. If you're a small organization, you probably get a bigger payoff than a larger organization, but that's depends on what the technology is. So then the downsides of cutting edge technology and software development are adoption and implementation costs. It does cost something to adopt something. So you have to change your workflows. You have to teach people how to use it. You have to, implement something. You have to go to your operations team and you have to have them buy into it. And that takes their time. There are maturity and stability issues where if it's not mature enough, especially if your other parts of your process are mature, it can be a weak link. And then, of course, limited community support. So having support, sometimes the organizations that make these technologies offer support, sometimes they don't. And so you have to go to the community. And sometimes the community can help you, and sometimes they cannot. And so if there's no support anywhere, then that makes it really hard. Or if the support is really kind of uneven, then that can be a problem. So this is, and then they give some ideas about how businesses can keep their software development projects on the cutting edge. And it's just really about being smart about these kinds of investments. And then this is a Medium post from Naeem Islam on unlocking excellence, advanced strategies for cutting edge software design. So this is thinking about these kind of strategies for this cutting edge, how to make the most of it. This is, of course, a roadmap where, we have, this is, I guess, AI generated because some of the words aren't like words. But the point is that there are a lot of different obstacles and things to think about on your way to this cutting edge benefit. So, of course, we have to think about software design as being this ever evolving landscape. In this landscape, being proficient is no longer enough. Success now demands a keen understanding of strategic design principles, security considerations, and the latest design trends that go beyond aesthetics. With artificial intelligence becoming integral to software development, cloud-native technologies reshaping infrastructure, and user-centric designs focusing more on accessibility and inclusivity, your ability to navigate these elements is key to staying ahead. And so this is where, to give you a comprehensive overview, we'll dive into the following key aspects throughout the article. So they focus on strategic design principles. So thinking about how to incorporate the cutting edge into your sort of design of your whatever you're doing, your design process, how AI is revolutionizing design by enabling advanced personalization and automation, the rise of agile and adaptive software design focused on flexibility and continuous improvement. So this is where we're intersecting with project management techniques. And I mentioned before sort of this need for DevOps as a strategy. So, as a developer, you want to adopt these new technologies and bring them into your organization, but your ops teams may not have the same view on what is workable from their perspective. So having a DevOps sort of approach to this might actually be quite a lot better than just simply adopting the latest shiny thing. And then, of course, agile is also an important part of this because you adopt something, you can use an agile approach to sort of iron out the kinks. So it's a very fast mode of development where you can maybe prototype something, see what you did wrong, do it again, keep doing it, getting feedback from your team, and you can kind of figure out what your sort of processes from that. Then they talk about the importance of security by design, particularly with the rise of DevSecOps, which is where you have your developers, your security people, and your operations people all in sort of integrated teams, ensuring software is secure from inception. And then trends like data visualization and ethical design, helping designers balance innovation with user well-being. So this is kind of talking about how we need to think about all these things as we adopt these cutting edge technologies and how to make the most of them in our organizations. Okay, so this is just kind of talking about strategic software design principles for 2024. And this kind of gets into some things that are sort of trendy in that area. And again, I don't know, like, this is kind of undercutting the article because it's like there's some of these things are not words. But anyways, we do have inclusivity and accessibility, designing for everyone. And so it's not just technology sometimes that are these overarching sort of shiny new things, but sometimes it's process itself. So if we have inclusive design, we have to have a strategy for inclusive design. A lot of organizations will embrace something like that and say, we want to do that thing in our organization. But then they maybe hire one person to do it. And whereas really to do it justice, you have to have this sort of integrated across your organization. So it doesn't make sense to just throw all the responsibility onto one person and say, that's what we're going to do. It makes more sense to have that as part and parcel of your design process. So it really depends on how it's integrated into the organization itself. Is this a value that people share, or is this just something that you feel like you have to do? And it's important to get that right. Then there's minimalist and clean design. Less is really more. So being able to have minimalist design principles. And again, it's a value more than a technology, but it's still important to use sort of have the similar approach. Advanced personalization through AI, voice user interfaces and conversational UI, agile and adaptive design, and thinking about that in your organizations. So the thing about agile is that a lot of times people use it as a buzzword. But it's really, you have to practice it and practice it properly to get the most out of it. So this is a thing that kind of almost breaks this mold of where you have, the bleeding edge, the cutting edge, the lagging edge, and the rusty edge, and that kind of typology. Because agile is one of these things that at one time was like the bleeding edge. and then it was sort of the cutting edge, and now it's sort of established as a project management technique, but there's still a lot of innovation within it. And most importantly, there is this aspect of applying Agile properly, because a lot of people will apply it as a series of buzzwords and say, well, we're doing Agile and we're doing iterative design. And then their process doesn't really match that. And so they don't really get the benefits out of it because they don't know how to apply Agile in their organization. And so Agile is maybe a microcosm of all of this discussion because, if you're not applying Agile properly in your organization, but you're just using the buzzwords, or you're just going through the motions, or you don't really understand what Agile actually does that improves productivity, then you would probably dismiss it as something that is a waste of time. And it's just kind of a thing that we run into that kind of transcends this whole model. So I hope that was useful, at least thinking about this topic. But I think, it's an important point because a lot of times organizations will do things either kind of out of the current trends, or they see something that they think is really promising, and then they don't translate it well into practice, where they don't really understand what they have in their hands and they lose the potential. Barshan.
But so I had a question like, so cutting edge is basically bleeding edge, but the bugs are fixed.
I guess that's one way to look at it. Yeah. It's also, kind of like it's been around longer, more people have adopted it. There's more support, or it's like, if I introduce like a piece of software, well, if I introduce this new method today for like doing open source development, a lot of people aren't going to understand what's going on. I can read documentation, but just the context is not there. And no one uses it, so no one knows how it works. But it looks great. So let's just adopt it. And then you get people who adopt it, and then eventually they start working with it, and they get some people get disillusioned. Some people actually work to iron out the bugs. And that's when you get to like kind of cutting edge, is when they're starting to realize the potential of the technology, but it's not quite at a stage where you have really solid use cases or really mature components. It's kind of in that middle ground. Yeah.
So bleeding edge just comes with risks, and we don't know if it's going to work.
Yeah. Well, it's cutting edge too, but bleeding edge especially.
Okay.
Yeah.
Yeah, that was
No
a
problem.
good article.
Okay, yeah. All right, yeah. So again, we can discuss this more in the Slack or wherever. So I think that was a great meeting. Thank you, Barshan, for giving your update, and Ashu and Morgan for their contributions here, and Sarrah, thank you for coming and visiting us. And I don't know where Jesse is, but hopefully he's okay. We can maybe do something next week on Joe Pro. All right. Thank you. See you next week.
Thank you.